We are seeing an almost unstoppable proliferation of Internet of Things. This has already led to the development of value-added smart services using cloud and fog computing. Compared to cloud computing, fog represents a number of potential advantages which are complementary to those of the cloud, including real-time processing, privacy of data storage and analysis, collaborative and federated access to devices in the near proximity, as well as new market opportunities with rapid innovation possibilities. The increasing usage of both paradigms in tandem offers unprecedented opportunities to develop new applications and architectural concepts that were not possible before. The mF2C goal is to design an open, secure, decentralized, and multi-stakeholder fog-to-cloud management framework that provides transparent and efficient use of resources across fog and cloud environments. It will include novel programming models, privacy and security, data storage techniques, service creations, brokerage solutions, SLA policies, and resource orchestration methods. mF2C will generate new business opportunities for industrial stakeholders, for fog and cloud providers, and service and technology providers who will be able to provide new services and generate new business models. The proposed framework is expected to be validated in 3 complementary scenarios: emergency situation in a smart city, boat enriched navigation services, and the airport smart fog hub service. In the consortium, we have industrial cloud and IoT solution providers like Atos, Intel, WorldSensing, 6SQ, XLab and Engineering, as well as academic and research institutions such as UPC, TUBS, BSc and STFC.
Internet of Things, data management, cloud computing, and the recently coined fog or edge computing are all novel concepts that, although are increasingly used by millions of people in their daily lives when running services, they all put together a set of research challenges. It is widely known the fact that technology in the ICT world is evolving pretty fast, what definitely facilitates both the deployment of novel services as well as novel functionalities or a much better performance on already deployed services. This scenario is even enriched by the unstoppable deployment of smart devices. For example, smartphones featured smart cars, smart city infrastructure, and so on, making user engagement to the smart world much easier. However, this very attractive scenario may be put in risk if such a bunch of resources is not properly managed. Aligned to this need for controlling the whole ecosystem, the mF2C project focuses on designing a management solution for the whole set of resources available from the edge up to the cloud. In other words, the mF2C project makes the most out of smartly combining fog and cloud computing through open interfaces software compatibility. Indeed, the project aims at designing a strategy to properly manage all possible resources, from a data center located at the cloud up to small sensor located at the edge of fog, seeking for an optimized service execution, even considering parallel execution. To that end, the project proposes an open service and technology agnostic light architecture, turning into different fog and cloud layers, all hierarchically managed through a control architecture supported by the definition of specific roles and tasks. In particular, the project proposes a clustering policy where resources may be grouped and led by specific devices, embedding the main management functionalities, all in all, in a completely secure and private context. Many different research avenues are devised to handle such a scenario, including solutions for service decomposition, allocation, mapping, and orchestration, programming models, or for managing resources, volatility, categorization, naming, and clustering. But this is not all. The resources scenario envisioned by the mF2C project also pushes for a collaborative model aligned to the recent collaborative economy trend, where proprietary resources, for example, those owned by individual city governments and so on, may be shared, setting dynamic clusters aimed at increasing the set of available resources, but also opening novel business opportunities. Indeed, new business models are expected to come up leveraging the mF2C envisioned collaborative model, also attracting new actors to participate, such as smart cities, OEMs, or community of users, and this is actually a key activity in the project. The project runs in 2 sequential iterations, 18 months each, and is built upon 3 diverse real-world use cases: airports, smart cities, and navigation, all provided by project members, where the prototype of the management architecture designing the project will be deployed and validated.
I'm Antonio Salis. I've been working for the Engineering Informatica Group. I'm a seasoned project manager in charge of the project management office in the Telco and Media division. In the last 10 years, up to 6 months ago, I've been also Chief Information Security Officer at Tiscali, so dealing with privacy and information security of a telco company at both organizational and operational level. I'm involved in research-funded projects like Horizon 2020, where I contribute mainly for project management and business development. I collaborated to the mF2C project proposal from the very beginning, and I'm playing the role of exploitation and dissemination manager. I'm leading the development of the use case 3, which is experimental and based in an airport. The idea behind is foreseen when in Tiscali is that value will be created at business service level, particularly in spaces with a high concentration of people and objects that communicate and interact. This scenario are typical of airports, railway stations, seaports, shopping center, hospitals, sports facilities, large parking areas, but also domestic scenarios with a communal clustering level. Made the choice of the airport, we are interested in setting up fog hubs to interact with all objects within the scope of coverage, offering useful services, proposing advice on the best moment to use the available service. In the case of the airport, a passenger departing with a specific flight could be alerted when the check-in or the security check queue is shorter than the average, or invite the passenger to move close to the gate, but also determine congestion or bottlenecks in service provision, or to operate in proximity marketing efforts, proposing best shops and offering close to the current position, or better, applying predictive algorithms to track in an anonymized form movements, choices, and decision on person nearby, or even extend the hub with devices like beacons capable of sending customized advertising and determine the effectiveness of the specific campaign in terms of visits rather than purchasing of product or services.
In general, urban areas have experienced a massive population growth. This situation directly affects city management and leads to increasing environmental problems. Nowadays, some technologies and devices, such as the autonomous vehicles, for example, are gaining a special interest by authorities and citizens to assess the impact that incidents or alarms may have on the city's management and population. In this context, the proposed use case, Emergency Situation Management in Smart City, aims to validate the implementation of novel technologies able to improve the management of emergency situations in smart cities. Such use case is based on the deployment of distributed edge elements, which are capable of capture signals and data, as well as centralized server, which integrates heterogeneous information in a cloud platform. The fog-to-cloud paradigm will allow to the aforementioned hybrid architecture a more efficient management of detecting incidents, both physical and cyber, for improving the performance of today's smart city systems. The proposed use case will be adapted to a list of different scenarios: smart building, smart industry, etc., to thus evaluate the agnosticism aspect of fog-to-cloud paradigm.
The smart boat use case is focusing on intermittent communication availability in fog and IoT environments. The vessels, like yachts or boats of different sizes, generate large amounts of data useful for either safer boating or for potential business cases, ranging from insurance to social media. However, not every marina has a strong wireless connectivity, nor is within the range of mobile network. To make matters worse, larger yachts quite easily move to open sea and thus lose mobile network connectivity, or at least change the mobile operators very frequently due to poor reception. However, all the data still needs to be processed and stored in the cloud, not to mention that sailors should be able to run at least some of the fog applications on the vessel or on a subset of vessels nearby without the connectivity to the cloud. The smart boat use case brings more dynamics, like unreliable connectivity and opportunistic resource sharing, into the mF2C concept. Using this use case, we will explore the possibilities to run mF2C in such conditions, expanding its potential exploitation reach.